Hello everyone, my name's Rachel and I'm one of the TAs for Macromolecules this quarter. I'm going to give you a brief intro to PyMOL, which is the program that we'll be using in our in-class exercises for the protein structure section. And PyMOL is a molecular visualization software and it's primarily used for analyzing and interpreting the structures of proteins. The first step is to download and install PyMOL on your computer, and you can check out the PDF files attached below this video in order to get those instructions. Second step is, if you don't already have one, find yourself a 3-button mouse to use for the course and for navigating PyMOL. It's a lot easier to use PyMOL fully with 3 buttons rather than just your trackpad on your computer. There's a couple different ways to import your protein into PyMOL. One is to navigate in your files to a PDB extension, which PyMOL can open. If you don't have the PDB file for the protein you're looking for, you can go to the Protein Data Bank, which is a database used to collect all structures from NMR and X-ray studies on proteins. And here you can search by author, the name of your protein, even the sequence or the drug that is bound to the protein, etc. PDB files have a 4-letter code. So here the M2 muscarinic receptor has the code 3UON, and if I want I can download files right here, and that will give me a PDB file which I can import into PyMOL using the file open command. Another way is within PyMOL itself, use the fetch command. 3UON. And this brings up the structure that I was just looking at. So if you know your 4-letter codes, and they're usually listed in papers, then you can bring that into PyMOL just using fetch pretty simply. Okay. So now we have over here on the right hand side, you can see all the objects that are loaded into our current PyMOL session. And the PDB file is one of these objects. You can also create and open multiple objects within the same session and save that session by going to File, Save Session As, and then you will save this as a .pse file, which can be loaded back into PyMOL containing all of the molecules that you've worked with. Another way to save a molecule once you've made changes to the visualization within PyMOL is to go to File, Save Molecule, and then you select the object. You'll have a full list here if you have loaded in more structures or created more structures within the session. And then this one is saved only as a PDB file, so just the one molecule, which we'll open up the next time. I'll give you an intro to the viewer window we're looking at here. Right here is a command line, and this works with most standard command line commands as well as some PyMOL specific ones. And if you are looking for the full suite of PyMOL commands, you can find those at a really great reference, which is pymolwiki.org. So anytime you have a question about how to tell PyMOL to do something, you can assume that PyMOL is capable of doing that thing and find it in the wiki. So the command line we used for the fetch command already, and we'll use it a few more times in class for loading maps into our structure. Down in the lower right hand corner is how your mouse is controlling the screen. So you can see here that I'm in 3-button viewing mode, and this is listing my left, middle, and right and wheel buttons, and middle means pushing down on the wheel. So you can see that left is going to rotate the structure, so if I left click and drag, it's turning the structure around the z-axis. M is the move button. So if I hold down on the middle mouse wheel, click and drag, I can translate the structure across the screen. The wheel button, if I scroll on the wheel, is changing the clipping plane, or essentially the stack that we're looking at, so you can view kind of the entire structure, or you can view only one XY plane within the structure. And finally, the right button is a zoom. So if I hold the right button and move it up and down, it's zooming in and out on the structure. Where we see the different objects, there's an on-off selection toggle, so if I deselect 3UON, it hides my entire structure. And this is useful as you create more objects. You'll have a full list here and you can hide and show things as you need. So just clicking on this with the left mouse button deselects that object. Next to each object is a series of 5 buttons: Action, Show, Hide, Label, and Color. And I'll walk you through the important features of each of these. Within the action, you can zoom, orient, center. This is useful if you forgot your 3-button mouse. It can get you back to the center. We'll go through some of these more complicated features in class. A very useful one is to be able to rename your object. So I clicked Action and then drag down, holding down my left mouse button, and release the left mouse button over renamed object. And over here it gives me a little dialog box where I enter my new name, which in this case will be M2. So now you can see that the new name is updated over here. This is pretty handy when you're working with command line. You can name things pretty short and simple. Another important feature is to be able to look at the protein sequence, and to do so you click Display, Sequence On. So now we have the linear sequence, and above, so here this is residue 216 that I've selected. Every 5 or 10 residues, it shows you a number corresponding to that residue. And you'll notice that there are some breaks in the numbers here, and this is just a convention that is used in order to delineate different sort of sub-chains within your overall protein structure. If I click on any residue within the sequence or within the structure, I can select that residue and the ones nearby pretty easily just by left-clicking and dragging my mouse. So if I want to select residues on the structure, I want to zoom in to get a better view of the particular residues I'm looking at, and then I can just left-click them individually. You may notice that if you left-click, it selects all of the residues in the structure, or you left-click and it selects only one atom in the structure. And the reason for that is down here in this lower right-hand box. Right now it's showing me the selecting mode that I'm in, which is residues. So if I left-click on the word residues, I can toggle through a bunch of different options for selections. So if I'm selecting chains, and I click on this molecule, it selects the entire chain. And if I'm selecting atoms, I can individually click on atoms at different points within the structure and select those. You'll notice that each time I make a new selection, this box comes up a new object, which is the selection object. You can actually rename this selection to sort of save it. So if you've selected a group of residues that you want to reference later on, this is a really good way to keep track of those. So you'll notice if I click off to the side here with my left mouse button, the selection box is deselected in the Objects menu, and if you click here again, it's going to reselect those same residues. But it only remembers its most recent selection, so it's a good idea to rename your selections if you need to come back to them. It's useful sometimes to be able to visualize different parts of the molecule separately. So for example, if I want to take a look at the first alpha helix in this protein, I can start from the very end terminus in the sequence and select all the way through. And here it looks like we're turning a corner, so I'll back up and just select what looks to be the first alpha helix. Now with selections, in order to view this molecule, this part of the molecule on its own, I can go to Actions and Copy to Object. It's important to, in general, you're never going to use Extract Object because that will actually take apart the M2 structure. And now I have this new object 2, which I will rename to helix 1. And Now I'm viewing simultaneously both M2 and helix 1. And if I want to view helix 1 on its own, I just simply deselect M2. So now you can see the first helix just by itself, and I'll go through some of the different show options. Under the Show tab, you can show line, sticks, ribbon, or cartoon views of the molecule. If you want to layer on different views, this is how you do that. So here I can add on ribbon, for example. So now I'm seeing both line and ribbon views. But if I want to show it only as a ribbon, I select Show As a Ribbon. That removes the line view. And one of the more useful views, I think, is Show As Cartoon, which really gives you a visual representation of the alpha helical structure. Within Show, there are some other handy tricks. So you can also show individual selections. So let's say I wanted to select just one residue within this, and under the selection I'm going to say show spheres. Now I can see a sort of ball and stick representation of that particular amino acid side chain on the helix. Other useful functions within Show, if I go back to viewing the M2 structure, so I'm going to deselect helix 1, go back to M2, you'll note that we lost that cartoon view because that was only for the other object. Under Show tab, I can look for disulfide bonds within my molecule, and this is pretty subtle, but you can see one that just was shown up here in stick representation with a little bit of yellow color. So the yellow color is now representing sulfur atoms. If I want to change the coloring scheme, you can color by the different atom types by going to the Color tab, Spectrum, by element rather. And here there's a whole set of color schemes, so you can set carbons, hydrogens, nitrogens, oxygens, sulfurs to whatever colors you choose. You can also just color the whole thing blue if you want. And I like cartoon view, so I'm going to show as cartoon again. So now we're getting a better idea of the overall secondary structure with alpha helices in this protein. And finally, just to round out the rest of the tabs here, if you select hide, you can hide certain parts of the molecule or the whole molecule. And then if you want to show it again, you can just select show as. Over here you can label. So if you're zoomed in on a particular region of the helix and you want to know what amino acids are within this region, one way is to select them individually, then scroll through the display list and realize that you selected here a valine and a glycine. Alternately, you can label residues. And so here now, within the selection, I'm seeing valine 36 and glycine 40. If you wanted to make a figure, say, for a publication or for a presentation, PyMOL has a nice feature that allows you to sort of make publication-ready figures. And the way to do that is to go to Display first. We want to change the background to white. By convention, your background should be white. And okay. So I just removed the labels there. And now you can go up to the upper right-hand corner where there's a set of buttons that are for different visualizations of the molecule within PyMOL. If you select Ray, it creates a ping image of your protein, which you'll see is much higher resolution and also includes some shadowing and beveling of the helices. So here, if you wanted to save this image, you would use the command ping and then name it into ping. And by default, this will go to your home directory. A couple other useful extra tricks. If you want to see how this protein was crystallized, how it packs within the crystal lattice, you can go to Actions, Generate, Symmetry Mates. And I'm going to say within 12 angstroms. And I'll hide the display so that you get a better idea. So here it's showing me the crystal lattice packing, so multiple molecules within the crystal. Now, if I want to clear that view easily, I can hide everything and then just show M2 again. If I want to align one structure to another, let's say I want to align these two together. They are in fact the same molecule, but just for purposes of teaching, I will rename this one to M2B. Okay, so now you can just use the align command, and then first you specify which molecule you want to move. So I want to move. Actually, I'm going to recolor this one so that it's easier to see. I'm going to align M2B onto the position of M2. And now they are, in fact, superimposed, and you can see that if I deselect M2, M2B is hiding right behind it. One last useful tidbit is being able to color by temperature factor, which is something we'll go over in class. So under M2, I'm going to select Color, Spectrum, B Factor. And you get a rainbow view here, which we'll talk about more in class during the exercise. Okay, so you can play around with a lot of the different buttons and commands, but that should give you a good idea of the basics of PyMOL and what you can do with it. See you in class.